In this video I'm going to talk about the new GIS features in Vectorworks 2020, GIS standing for Geographic Information System. And this is becoming increasingly important as we gradually move to a 3D workflow in both architecture and landscape design. And it's important because when you're exchanging information between different consultants, you want that information to appear in its correct location in the universe, or in this case, on the surface of the Earth. Now I'm just going to talk a little bit about projections, and this is part of GIS. So the Earth is a sphere, and yet we want to represent it on a flat surface, and CAD is flat, essentially. A CAD drawing ignores the curvature of the Earth, and for most buildings it's such a small amount that it's not worth worrying about. But in larger infrastructure projects it actually becomes very critical, and you could be working on buildings that are spread apart by a long distance, in which case it is important for that as well. So with projections, the most commonly used one is the Mercator projection, and you'll see that Google uses that. But there are various other ones as well, and the Mercator projection is a cylindrical projection, so it takes the Earth and it projects this onto a cylinder, then unwraps that cylinder. So here's a more detailed view of it. There's a light source in the center of the Earth, and it projects through all of the continents and creates this map which is stretched out. So then the Mercator projection kind of squashes this down a little bit, but you still get differences in the distances between the latitudes. You can see that these are getting further and further apart. The transverse Mercator projection, or the universal transverse Mercator projection, or UTM as it's known, actually does this on its side, and this is the one that is typically used to draw maps. And so here's what we're doing. We're taking the Earth, we're projecting it onto a cylinder, we're unwrapping that cylinder, and we end up with our drawing like this. And the Earth is then divided up into UTM zones. And let's have a look at those. So here they are, starting at 1 and going all the way up to 60. And you can see with Australia here, Australia is in the zones 49 to 56. So this becomes important in understanding how the projections work with Australia. Now each of these little divisions here represents 6 degrees. So 6 times 60 represents the equator at 360 degrees. This image here kind of shows you the true sizes of countries compared to what the Mercator projection shows them at. So Soviet Union here looks very big on the Mercator projection, but it's actually a lot smaller. Same with Canada, Alaska, the USA. But closer we get to the equator, the less distortion there is. Australia actually isn't too bad in this regard. So what we're going to do is to actually look at the new Geolocate Tool, the Geoimage Tool, the GIS Stake object, and we'll then import a shapefile, we'll import an IFC file, we'll import a DWG file that are all georeferenced, and you'll see that they all then go to the correct locations on the surface of the Earth. Now I mentioned a moment ago that Australia used the UTM zones 49 to 56. And this illustrates that in more detail. So this line up here represents the equator, and I've drawn here these zones which represent 49 up to 56. Now each of these zones based on UTM zone is 6 degrees. So there's 6 degrees around the equator between this point, and 6 degrees is a roughly 670 kilometers. But Australia actually expands these zones to create the MGA zone, mapping grid of Australia zones, and the mapping grid of Australia zones are actually still centered on these MGA zones, but the mapping grid of Australia zones are 1,000 kilometres wide. So the zone 56 will overlap zone 55, and zone 55 will overlap 56 and 54. And as a result of this, it is possible when you order a survey that where the property sits somewhere very close to the intersection of two MGA zones, that you can request it be in zone 55 or 56 or 53 or 54. Now, looking at this in each of these zones in a little bit more detail, so what's going to happen is that in order to project this and make it useful, we're going to take this shape and project it basically so that it's flat and square. And looking at MGA zone 56, which is this one here, this is what we get. So this is essentially the MGA zone 56, and this would be MGA zone 55. And if I make both of those visible, you'll see that the zones actually overlap. So you can see here that these two MGA zones actually overlap. Okay, so with our MGA zones then, the idea is that they're 1,000 kilometres wide, as I mentioned. They're 10,000 kilometres deep, starting at the equator up here at the top. So they all start at the equator and they go down 10,000 kilometres. And sometimes you will get a drawing that has its origin at this point here. And that is because in this MGA zone, that will make all the values positive. So values in the X direction or the easting direction, and values in the Y direction or the northing direction. So eastings and northings will be positive from this point at the bottom here. And you'll see we'll just go through showing you the other zones. So the map of Australia actually rotates behind here because that's taking into account that we want each of the center of each of these MGA zones to be vertical, north facing. And so this is what the projection does in order to make the whole system work. Now, I am no expert in this whole area of projections and stuff like that, so I could well have oversimplified things or made wrong statements here, but hopefully this just gives you some idea of how the projections work, and it will give more relevance to what you're about to see in terms of what Vectorworks can do now. You're going to find the new GIS tools in a new toolset called GIS. And when you click this, you'll see two new tools at the top: Geolocate, Geoimage. The Stake Object, Graticool, and Great Circle are existing tools. So in order to georeference a drawing, what you need to do is to click the Geolocate tool, and you'll get this warning dialog, which you click OK to, and then Vectorworks is going to ask you what georeferencing system do you want to use. And we need to click Use Common Coordinate System or enter well-known text, WKT. And for Australia, we need to go to Country-Specific Coordinate Systems and choose GDA 94. Then we need to look at the coordinate system lookup, so we click that button, and it's a bit easier if you type MGA here. And we're going to be working in Sydney, and I know that's in GDA 94 MGA zone 56, so we choose that. Australia is divided into different zones, and essentially we've now nominated the georeferencing for the document. We now need to make sure that this is being used by this layer. So if we right click and edit the layer, we make sure we have this georeferenced option, and it's going to pick up the document georeferencing settings. And while I'm here, I might just change this layer name to Geoimage, and you'll see why I do that in a moment. Alright, so we've georeferenced the document. Now we've got to say, well, where are we in the world? And we do that by clicking the search mode button up here. and you can type in a locality. Now the one I'm going to demonstrate is Paddington, New South Wales. So you can just put a suburb name in there, and you can hit return or click the search button. And depending on your internet connection, Vectorworks is then going to connect to the Esri servers and look up anything that has the word Paddington, New South Wales in it. And after a little while we'll get a list of matches. Here we are. And locality is generally a good one to pick. You can see that, so we'll choose that, click on that, and after a little while you can see that behind us a map of the suburb of Paddington has appeared behind us. So at this point we can just click OK, and now we have to locate our site of where we are actually working in Paddington. So what I'm going to do is actually just zoom in a little bit here and click on the roundabout in 5 ways there, because I don't have a specific site in mind. And what that does, it puts the internal origin close to your site, and this is going to resolve a lot of those issues that you're going to have when you have a distant origin because you've imported some drawing and haven't taken into account the fact that the internal origin needs to be near your geometry. So that's the first problem solved. Now it's common that you will want to have this image in your drawing, and as soon as I deselect the tool, this image will actually disappear. But before we do that, I just want to mention one other thing. It is quite common for a site to not be oriented with north facing directly up the page, and you can use this rotate mode to actually readjust the angle. I won't demonstrate that now, but that's what you can use that for. As I was saying, it's quite common then that you'll actually want a portion of this image on your actual drawing. So with the Geoimage tool, I can draw a rectangle or a polygon and define an area that I would like to see on my drawing. And you'll see up here that I can choose the satellite image, I can choose the map mode, or I can choose service mode. So there's a number of different ones that I can choose. I'm just going to go with the satellite image, draw a rectangle, and after a moment that image is going to be fixed. So now when I deselect the tool, you'll see that this image is going to stay in the drawing. Now this is an interactive image, and by that I mean if I move the image, you'll see that the objects in the image actually don't move. So this image is a window into the surface of the earth, and I can keep moving it around, but I've set the location of where I am in the world. Now one thing to note is that when you quit Vectorworks, this image will actually go away. It can only display when you have Vectorworks open, and as a result you'll need to click this update button here when you reopen a file to get the image to appear back in the drawing. And I guess you only need to do that when you're printing or something like that, where you need to output the drawing. Once you have a GeoImage object in the drawing, if you no longer need to have it linked to the Esri servers, you can simply ungroup it and you'll just end up with a bitmap that's no longer linked. So to do that, literally just modify, ungroup, click yes, and you then get a bitmap. But the bitmap is just a bitmap, it's no longer linked to anything. Let's take a look at the modified stake object that we get in this tool set. Before I do that, I'm actually just going to delete this GeoImage from the drawing, because you'll see that when you select the GIS Stake object, it will actually put in a temporary aerial image, map, or nothing, depending on which of these three items is selected here. And that allows you to see where you are. And if I was to then click on a point, you'll see that it's showing us the northings and eastings, If we wanted to switch it to eastings and northings, we can do that. We can choose the units, precision, and so on. And this is obviously completely interactive, so that if you move it around, then it's going to change in relation to the georeferenced document. Let's now look at the new import for georeferenced DWG files. So you import it in the usual way, import single DXF DWG. And if the file is georeferenced, then you can check this box here that says this file contains georeferenced geometry. And then a couple of things to check. The location will align with internal origin because we've already set where the origin is and what the georeferencing is. You probably want to check the scale. I'm just doing all 2D for this. And we're importing the geometry using the document's coordinate system. So when we click OK, we'll go through the normal progress dialog, and we've got a new layer in the file. And if we go to show others and we zoom out a bit, you'll actually see that this image and this information all coincide exactly. So we'll just go to show snap others, and if you recall, this is the Geoimage and it's interactive, so as we make it larger it's just going to read in more information, and you can see that it all marries up perfectly with the DWG file that we've imported. Tenniel Park down the bottom here. Obviously the harbour, and those who aren't familiar with Sydney, just to show you where we're talking about here. We just expand this a little bit more to the left. We're going to see the Opera House on Bennelong Point there, and the harbour bridge is up here. So this is the site that we're dealing with. Now, although I imported this DWG file into my working drawing, our normal recommended workflow is to use a shuttle file. So in other words, you create a new Vectorworks document, you import the DWG file into that document, and then you reference that document into your working file. I just want to describe how you do this, because you need to have the georeferencing set up exactly the same in both your working file and in the shuttle file. So if we jump back in here and take a look at the georeferencing for the document, you recall that we set it up to GDA 94, MGA 56. So what we need to do is to copy these three values here and put them in our new document. If we had rotated the document, then there would be an angle here that wasn't at 0, but we haven't done that, so we only need, in this case, these two values. And the easiest way to copy these is to copy the first one, click in here, paste, and we get the two values in one field, and then I can select that whole field and copy those two values to the clipboard, click cancel. So now if we create a new blank document, and I'm going to set the layer scale to be the same, and then go to document settings, georeferencing, and I'll paste in here what we've got on the clipboard. So we just need to take that value there and put that in there, get rid of the space that was there, and that's got these two aligned. In terms of the latitude and longitude, then we have to set up the same coordinate system. So we go to country specific, Australia, and then we do the lookup. 56. So now these two documents have the same georeferencing system, and we just need to make sure that the layer is georeferenced. So let's now go ahead and import the DWG file in here, and we'll just go through and do the same settings. Check that we did 1 to 5,000 GIS. Okay, and so we've got that in there. We can save this. Alright, so that file is saved. We go back to this drawing and we create a viewport. Create on layer. I could just put it on the same layer as this. Select source, external document, choose shuttle file, and we'll just leave all of the other options as they are. Click OK, and you'll see that, if we just turn off that Geoimage layer, you can see that these two DWG files exactly coincide with one another. And if I was to move this one, you'll see that we've got the two of them there. So that's how you can reference in a DWG file, but make sure that the shuttle file has the same georeferencing as the working file. So now that we've got our image, we've got the document georeferenced, we've got a referenced DWG file in here, I want to now import a shapefile. Now shapefiles can be 2D and 3D. They're typically generated by GIS systems like MapInfo, ArcInfo and so on. And they're widely used by local authorities. And you'll see as I've got one here for Wallara. So this is the land use one. It's a fairly old one, but it will serve the purpose. And shapefiles are typically georeferenced. It's going to create a new layer with that name, and it's going to use the existing georeferencing. And you can see that it's also come in here precisely in the correct location. And you know, one of the things about shapefiles is that they have a lot of data attached to them. So this has got information about every block, its zoning, its the area, the perimeter, and so on. That's not really what we need to worry about with this, but you'll just see if I make our image a bit bigger, you can see that it perfectly marries up with all of the information we've already got there. As I mentioned earlier in the video, if you have used GeoImage objects and you close and reopen the file, the GeoImage objects will need to be updated when you open the file again. And doing that is simply a matter of selecting one of the GeoImage objects and then clicking either update if there's just one object there, or if there are multiple GeoImage objects, you can click update all. I'm not going to do that at the moment just because you'll see more clearly what I'm about to do, which is to import a georeferenced image. So a georeferenced image is an image. It can be a TIFF, a JPEG, a PNG, quite a few different image format types that is geolocated. In other words, the image has stored with it information about where it exists on the face of the earth. There are two ways that this can be done. It can be done when you get an image that has the information embedded into it, and you can also get it where you have two files. You have the actual image file, and then you have a world file that accompanies it, and that's what we'll be demonstrating here. So you just use the normal import image command. So you come here and you go import image file, and you'll see this is the image file I have, and this is the world file I just mentioned. So it'll have, if it's a JPEG image, it will be .jgw. If it's a PNG image, it will be .pnw, TIFF, TIW, and so on. So you'll need to make sure that you have the world file if a world file is in use with the image that you're importing. So we click open, and we get the normal dialog. We can just click OK to that, and you can see that the dialog says yes, we've imported the image, and the image was actually this portion here of Double Bay, and the image has come in exactly where it should have. I'm now going to update the Geoimage object, and when I do that, you're going to see that this image fits in perfectly well with the other image and matches everything else in the file. You'll recall that earlier in the video we set the internal origin to 5 ways in Paddington, and that's represented by this blue circle with the cross through it. And to make this visible in your drawing, you can come up to Origin and go Locate Internal Origin, and that will turn on this marker and show you where it is. And if you also go to Origin, User Origin, you can see if there is an offset between the user origin and the internal origin, and currently there isn't. You'll see here it says the user origin is currently coincident with the internal origin. Now let's say that in this project you had been given the coordinates of the site datum, and for argument's sake, let's say it was in the centre of the Sydney Cricket Ground, which is what I've got here in this stake object. And this stake object can display coordinate points, and I've got it set to eastings and northings, which is what we normally use here. And I've got it displaying as meters, but you can set it to decimal degrees or degrees, minutes, and seconds if that's what you want to display. Now, if you had been given the coordinates in degrees, minutes, and seconds, you can simply place a stake object, set it up to whatever settings you want here, and then click Set Geolocation. And when you do that, you can then enter the latitude and longitude in this dialog and just click OK. Probably more commonly, you will get these coordinates as eastings and northings, and so you're going to have to go out of Vectorworks to the Geoscience Australia website just to convert the eastings and northings into latitude and longitude values. And let's see how you can do that. So it's this formula here, Redfern's formula, and what you can do is to enter the eastings value here and the northings value here, put in the MGA zone here, which is 56, and just to confirm these values, so 335836, 335836, I could put more decimal places, so these values actually match. And then you click Submit Data, and you will then get the equivalent latitude and longitude, which you can plug in to the Vectorworks stake object in this dialog. Now you can use them in degrees, minutes, and seconds. The only tricky thing is that for some reason the Australian government has decided to use 2 characters here with a space after them for the seconds designation, and that's not going to work. So what you've got to do is to copy up to the end of the number, paste that in here, and then put a seconds indicator at the end there. And if we do the same here, copy just the text there, come in here and then put the seconds in there, click OK, and you'll see that this didn't change because it actually went to exactly the same location. So once you've located where the site datum or user origin should be, then we just need to use the set origin command. And let's come in here, and it's going to be right on this point here. So what we do is we come up here, we go Tools, Origin, User Origin. We can go Set User Origin to next mouse click, click OK, click on this point, and now we have set the user origin to that point. And if this was an important datum to have in your drawing and you don't want it to get moved, then it's probably not a bad idea to just put this on a layer by itself. I have a layer here called Internal Origin. I could put it on that layer and then go to Modify and Lock so it doesn't accidentally get moved. So if somebody does move the origin, you can easily set it again. And so now you're going to see that instead of this point being 0, 0, if we take, say, a 2D locus point and put it on here, it's going to have the X and Y offsets from this location here. So finally, I want to import an IFC file. And I have a little site here. It's just a small building. And here we are back in Paddington and Moore Park Road, and this is the College of Fine Arts here, and this is the site where the IFC building is. So we'll now go to Import IFC. We'll choose the building. We'll just choose all of the stories to come in. Now, not all IFC files are georeferenced, not all DWG files are georeferenced, all shape files are georeferenced. Okay, so let's just come in here now and locate our little building, and here it is here. If I render that in OpenGL, you're going to see that our building has come in precisely in its real-world location. So hopefully you can see there are some features of these new tools in Vectorworks that you'll be able to put to use in your projects.